Hi, in today's episode, I'll be talking about machine learning algorithm known as a random forest. You'll learn the theoretical basics of how it works and see how to implement it from scratch in Python. In the end, we'll use it in practice, which will deepen your understanding of the topic. Let's get started. Random forest is a supervised machine learning algorithm. It can be used for both classification and regression problems. As you may guess from its name, it has a lot in common with the decision tree algorithm which we covered in the previous episode. In fact, decision tree is core element of random forest since it relies on many decision trees, where each tree is built from a random transformed subset of training data. Each tree makes its own prediction on a new data sample, contributing to the final outcome. It does this by voting in the case of classification or averaging the result in the case of regression. In this episode, I won't go over the basic principles of how decision tree works. So, if you're not familiar with it, please pause this video and check out my previous episode where I cover its theory and implementation. Knowing how we create decision tree from training data, we can move on to the next step, preparing randomly transformed dataset for each tree in the forest. We'll demonstrate this with a classification problem example. Random forest create a series of decision trees based on the training data. Each tree will look different because it's built from unique randomly transformed subset of the training data. This new training data is generated in two steps. One, from the original dataset described by features, only some features are randomly selected, while the rest are ignored when building the decision tree. Two, in the next step, we randomly select the same number of data samples, but in random order and with replacement. So many samples may be omitted, while others might be duplicated. So for each tree, we prepare separate, randomly selected data. The next step is the training process, where each tree strives to maximize information gain based on its own specific data subset. Finally, the training model evaluates a new data sample by making prediction through each decision tree and then selecting the most frequent label in classification problems or the average value in regression. We expect that this collective prediction will result in greater resistance to overfitting, higher accuracy, and more stable predictions. Now, let's see how we can implement our model. The first and most essential element of our model is the decision tree itself. Apart from a few minor differences in syntax and code organization, the decision tree class differs only slightly from its predecessor in the episode where I covered the decision tree algorithm. The concept and functionality remain the same, but I've introduced a few tweaks that allows us to build trees based on a randomly selected subset of features, which we specify in the class constructor. In the original version, this wasn't necessary because the tree was always built using all available features of the training data. I won't go over the entire code again here, so if you find any part of the code unclear, I encourage you to watch the previous video where I explain the decision tree implementation in detail. Of course, all the code will be available on GitHub, so you can always refer to it if needed. You will find the link in the description. For now, I will highlight the few places where the logic was modified so we can use it in the random forest model. The first place we need to update is, of course, the init method, where we add an extra parameter and features which defines the number of features to consider when building the decision tree. we store this value in class attribute with the same name. Next, we need to modify the best split method. The original version search for the best data split based on all available features. After the modification, we pass a list of selected features indices into the method, which then use those features to find the best data split. In the growTree method, we randomly select the features to be used in building the decision tree. These feature indices are passed to the best split method. In original version, all features were always used. The rest of the code remained the same. Now we can move on to creating a random forest class for classification. First, we import the necessary libraries. NumPy is used for matrix operations, Counter helps us count the most frequent labels, and of course we import our custom decision tree model, which we create earlier. Then we create random forest class. When initializing our random forest, we passed several parameters: the number of trees, the maximum depth of each tree, the minimum number of samples required to make a split, and the number of features to randomly select during the training for each decision tree. Our trees list will store all generated trees. The fit method is responsible for training our forest. For each tree, we create a new decision tree object. Then we use the bootstrap sample method to generate random training set by sampling with replacement, which introduces additional diversity into our model. Each tree is then trained on its own unique data. The bootstrap sample method selects random samples from our data, but with replacement. This process is essential for making our trees different from each other. The predict methods use all our trees to make predictions. Each tree makes its own prediction, and we gather this prediction, then swap rows with the column using swap axes to simplify the decision-making process. For each sample, we take the most frequent label, which becomes our final prediction. Finally, we have the most common label method, which simply returns the most frequent label. We use the counter class here to quickly count how many times each label appears and select the most common one. Now it's time to test our model. First, we import a few additional components from the sklearn library. We'll use the Iris dataset, which is popular in machine learning examples. We'll split our data into training and test sets and also measure the accuracy of our model using accuracy score. We import our random forest class, which we create earlier. Now we can use it to train a model on the Iris dataset and see how well it performs. We load the Iris data and split it into training and test sets. X contains the features of each flower, and Y is the label, which is the flower species. We use the train test split function to allocate 80% of the data for training and 20% for testing. Now we create an instance of random forest class with 10 trees, maximum depth of 10, and randomly selecting 2 features for each split. Then we train our model on the testing set, teaching the trees how to classify flowers based on the provided features. Next, we make prediction on the test set and calculate the accuracy of our model. We display the result on the screen so we can see how well our random forest classifies the flowers. This demonstrates how our model used the collective decision of all the trees to provide accurate predictions. And that's it for today on the random forest algorithm. I hope this video helped you to understand how this powerful tool works. If you found this content interesting and valuable, Consider leaving a like, and if you want to see more videos like this, subscribe to the channel. It would be a huge help in growing this channel and great joy for me as a creator. See you in the next episode.